Alright, in this section 4.1 we talk about solving systems of linear equations graphically and numerically. A system of linear equations is just two equations that are lines. Alright. Now if you want to solve it graphically, you just draw both graphs on the same grid, and wherever they intersect is your answer. That's the one point that they both have in common, and it's a solution to both equations at the same time. So if they ask you for a truck rental, it's 0.5x plus 25, and they want to know how many miles will it take for you, and if the rental cost is $75, how many miles is that? Well, you graph y equals 75 and y equals 0.5x plus 25, and you see where they intersect. And they intersect at the point 175, meaning 100 miles, you pay $75. So you came up with two lines. One line talking about rental costs, and the other one being the actual cost that you want to calculate out, and you can actually figure out the mileage based on that intersection. And you can do the same thing here. If this is your pay, and you're paid $10 an hour, it's just P equals 10x or Y equals 10x is your graph for your pay. And if you want to know how many hours you worked, if you were paid $40, so Y equals 40 and Y equals 10x, and you graph the two, and they intersect at 440. And what is that 440? That's 4 hours and that pay is $40. Now you could also graph it, right? Just type in under Y1 40 and Y2 10x, and when you hit graph, you see the intersection point right there. Now as long as you can see the intersection point, your calculator can find the intersection very quickly. Just hit second, trace, 5, enter, 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 and it gives you 440. Okay, so second, trace, 5, and then hit enter 3 times. And that will tell you the intersection. Now how do you find it using a table? Remember, to do a table you want to set up your table with table set here with second window. And you probably want to start at 0 and go up by 1, so it's already doing that already. Leave everything else alone. And now hit second and then graph, which will give you a table. Okay, and let me get rid of my old stuff here. Let's just type in, it's only what we need. We just need the 10x here. Okay, so I typed in y equals 10x, okay, and now I've got my table at 0, 0, 1, 10, 2, 20, 3, 30, 4, 40, and so on. So you just look where your pay is $40, and you look at the corresponding x value at 4. So to get a table, just hit second window, and then you start out typically at 0 and go up by 1, but you can change that if you want. 0 just tells you where your table starts at, and this number tells you how far apart your tick marks are. So you typically start at 0 and you go up by 1. Right? And then second graph will give you a table, and you can get any numbers you want from the table, arrowing up or down to get other values as well. So you can use a table of values, and that's what they show you here, where they graphed here and they show you a table of values, and that's exactly what we got here, right? What they actually do is they graph both on the same thing here, and they graph 40, okay? And then when you hit table, you're looking at where are both y1 and y2 the same value. They're both 40 right here, 40, 40, when x equals 4. So that's your answer. Whenever you have a table and you set up two different lines, you're going to have two y values for the same x value, right? So you can imagine this is the table with just these two, x and y1, and then imagine y1 is gone and you just got x and y2. So these x coordinates match up with y1 and y2. And you can use the table to actually help you to solve a problem. Or you can solve something graphically like this one, right? Y equals 3 and y equals 2x minus 1. And so they graph both of them on the same grid, and they find the point 2, 3. And the same thing here with this guy and y equals 3. Now, before they graph this guy, they can't graph minus 3x plus 2y equals 12, right? Because that is not solved for y first. You have to solve for y before you can type it into your calculator. So you can't leave it in that form. That's not good enough. You got to solve it for y. So you got to add 3x to both sides. 2y equals 3x plus 12. And then divide by 2. And so you get y equals 3 over 2x plus 6. So there's your one line. And that's what this guy is here. They don't show that they solved that in order to graph that. They just graphed it. But in order for you to do it on your calculator, that would be your y1, and your y2 would be y equals 3. And when you graph both those guys on the same line, you're going to find that they cross at -2, +3. All right. Now, if they give you a graph system of equations here, minus 3x plus 2y equals 12 and y equals 3, you can just plug in 3 into here and figure out what x needs to be. If you plug 3 in there and you plug minus 2 in there for x, and you get 3 equals 3, that's true. And we also know 3 equals 3 as well. Okay, so we know that -2, 3 is a true solution to this equation. Now when you have two equations, two lines, you have three possible outcomes. The first one is they don't intersect at all. They don't intersect at all. They run parallel to each other. And that's a no solution. Then you've got the ones that are one solution. Okay? Those are the most common ones. And then you've got ones where it's the exact same line twice. For example, if you've got y equals x plus 5 and 2y equals 2x plus 10. Those are both the same line. It's just I multiplied the first one by 2. But if you look at them and you don't recognize that, you may not realize that right away, but once you graph both of them, you'll only see one line on your graph. And that's what happens when you get this, when you got the same line twice. And it has infinitely many solutions. Now, the number of solutions is either 0, 1, or infinitely many. Okay? And if it has no solution, it's called inconsistent. Inconsistent. Otherwise, if it has one or several solutions, it's called consistent. All right? Now, these other two that have solutions, they're either independent or dependent. Now, these two are independent lines, so they're called an independent solution. Okay? And identical lines are dependent because it's only one answer, and it has the y is literally dependent on what the x does. So I will never ask you these questions on a test, but you might be asked these on your homework assignment. What type of solutions do parallel lines give? Well, no solution, inconsistent, and you don't have to worry about the type of equation. Intersecting lines will always give you 1. And consistent and independent, and identical lines are infinitely many solutions, consistent, and dependent. All right. So types of solutions: 1, infinitely many, no solution. All right. Now here they give you 2 points, and they ask you if they're solutions to the equation. Well, this is really two questions here. The first question is 4, 6 a solution to this system? So what you have to do is you have to plug in 4 for x and 6 for y for both of them. Okay, plug 4 and 6 in for x and y and see if you get a true statement. You do. Plug 4 and 6 into the second equation and you don't. Now, even though it worked for the first equation, it has to work for both. Otherwise, it is not a solution of the system. It's a solution to the first equation, but it has to make both equations true. So you would say 4, 6 is not a solution to this system. Now what about 7, 3? They plug 7, 3 in here and they get a true statement. They plug 7, 3 into the other equation, they get a true statement. So it is true for both. That makes the equation, the 7, 3, a solution to the system of equations. Alright? So you can solve things graphically or numerically. If you solve it graphically, you're going to have to solve for y first in each one, and then you graph each one on the same grid and you find it. All right. Now you can do that on your calculator, right? You can just type in each one of those under y1 and y2. Okay, so under y1 you type in -1 divide 2x plus 2 and 2x subtract 3. Okay, and now hit zoom 6. That's typically a good place to start. So there's your first equation, there's your first line, there's your second line. And as long as you can see the intersection point, your calculator can find it for you. But if you can't see it, you're going to have to zoom in or out until you can. Alright? So second trace 5, enter, enter, enter. And you get 2, 1. 2, 1 is your answer. Now what about numerically? Well, if you hit second graph, and we want to look where the y values are the same. Right here the y values are both 1 when x is 2. So 2, 1 is your solution using a table. Right? See where the y values are both 1? And then the x coordinate is 2, so the point 2, 1 is a solution to your equation. And so here again you can solve this one graphically and you find the intersection point right there. Now they talk about a word problem, but it doesn't matter if it's the word problem or not. It's still going to come up with two different equations. You come up with your two equations, you graph them, and you get an intersection point. All right. So we're talking about a system of linear equations in two variables. It can be written something x plus something y equals a number, something x plus or minus something y equals another number, and you graph both them on the same grid. If they ask you if a point is a solution, it must be true for both equations. And then you've got no solution, one solution, or infinitely many solutions. Alright, so let's look at the similar questions here. Here are the similar questions, so let's first look at number 19. Number 19, 21, and 23, they ask you how many solutions, is it consistent, inconsistent, and is it dependent or independent? Alright, so 19 has one solution, 21 has infinitely many solutions, and 23 has no solution. Now remember what I said before, if you refer back to your chart here, no solution, okay, it's inconsistent, okay, no solution is inconsistent, and one solution is consistent and independent. One solution is consistent and independent. So the other one that has infinitely many is also consistent and dependent. Alright? That's 19, 21, 23. Let's look at number 29. They give you some points and they ask you, are these points solutions to this equation? So you're going to plug in 2, 0 into the first one, 2, 0 into the second one. So 2, 0 into the first one gives you a true statement of minus 10 equals minus 10. 2, 0 to the second gives you 8 equals 8. That's also true, so it is a solution. And now let's try -1, -3 for both equations. For the first one, yep. For the second one, no. So it is not a solution. Even though it worked for the first, it's got to work for both, otherwise it's not a solution. Alright, 31, they say the graph of two equations is shown, identify the solution to both, so it's just a matter of looking at both these lines and you see the point, they both intersect at 2, 1. And that's all you have to do is just look at the graph there. Alright. 51. Solve the system of equations graphically. So you got to take each one of these guys, 2x minus y equals 3 and 3x plus y equals 2, and you got to solve them for y. And then I don't show the graphing that I did here, but I can do it right now for you. You can just type in, you got to get rid of your old data. Okay, so type in 2x subtract 3. -3x add 2. Okay, so I typed in both equations. Now I'm going to hit graph. There's the first line, there's the second, and I can clearly see the intersection. So second trace 5, enter, enter, enter. And I get 1, -1. Alright. And you can do the same thing here with both of these. This first one you have to solve it for y first, 4x minus 2. And the second one it's already solved for y. So here are your two equations, you type them in, you do the intersection idea there, and you get the point 1, 2. Then the same thing here, you solve this one for y, solve this one for y, and you type them both into your calculator and you find the intersection point of 3, 2. Same thing is done on both these. you got to solve each one for y, type it into your calculator, and find the intersection point. Okay, and then here you find this one, you find this one, and their intersection point is 3, 1. Now 67, it says a rental truck costs $50 plus 50 cents per mile. Write an equation that gives the cost C of driving the truck X miles. So I should have actually wrote C equals 0.50x plus 50. I shouldn't have used y because they want to call their function C here. Now, so you got this function here. It says use the intersection of graphs method to determine the number of miles the truck is driven if the rental cost is 80. So you've got one equation, and you've got the other equation is y equals 80. So you want to type in under y1 this and y2 that. You can't. You're not going to have a C1 and C2. Your calculator is in terms of y's, right? So even though it's C equals that, you type it in under y1, and this guy equals 80 for y2. And where do they intersect? They intersect at 60, 80. So 60 miles is your answer to the cost being $80. Right. The dimensions of a rectangle. A rectangle is 6 inches longer than its width. Its perimeter is 28. Write a system of equations in 2 variables that describes this information. Alright, so you got the perimeter is 28. And you know, if you don't know it, the perimeter formula of a rectangle is 2w plus 2l equals p. Well, p is 28, so 28 equals this, all right? Now, we also know that the length is 4 longer than the width. Now, the width is shorter, right? So if you want to get the width to equal the length, you've got to add 4 to it, because the length is 4 longer than it. Now, the most common mistake people make is they say, oh, if L is 4 longer, I'm going to say L plus 4 equals W. No. If L is longer, right, say this is W, and this is L, right, and if you add 4 to L, it makes it even more disparaging. It's not equal at all. The only way you're going to make these two equal is if you add something to W, so it will equal L. So that's what you're doing. You're adding 4 to W so that you can say that it equals L. All right? And so now you've got, you can write these guys in terms of L. You solve each one for L. L equals x plus 4 or W plus 4. And solve this one for L, and you get L equals this, and instead of L you write Y, instead of W you write X. And now you can type in both of these guys into your calculator, right? And when you find the intersection point, you find W equals 5 and L equals 9. All right? Determine graphically the x values when y equals 2. So you got y equals 2 and y equals minus 1 half x plus 1. It's just a matter of graphing it on your calculator. And you find you get the point negative 2, 2. Right. Determine if these points are solutions. So you plug in 0, 0 into the first one. And you get a false statement, so you don't even have to check the second one. Right. Then 1, 1. You plug 1, 1 into the first one. It worked. Yeah. Plug 1, 1 in the second one. Yeah, it worked. 0, 0. So 1, 1 is a solution since it worked for both equations. Notice if it doesn't work for the first equation, just stop and say not a solution. 27, we have to plug in minus 1 into the first equation, and we get a true statement. And we plug minus 1 in the second equation, and we do not get a true statement. Negative 1, 1 is not a solution. Now if we try 2, negative 3, we get true. And here we get true, so we can say 2, negative 3 is a solution to both equations. And then there's question 29. I don't know why I didn't show you number 29. Oh, I guess I did back here. 29, done again, is plugging in these points into both equations, and if it works for both, it's true, and if it doesn't, it's not true. It's not a solution.